Assalamu alaikum friends, my name is Bilal Khan. So today is my fifth video of DevOps. So this video will be started from a question, and the question is, if I have multiple devices connected to the internet, does each of them have different IP addresses or the same? So basically all the devices that will be connected to the internet will be having different IP addresses, but these IP addresses will be local, and one IP address will be used as a global to be identified on the server. Alright, so let's take a look at an example so that I can show you what I'm talking about. Alright, so let's take an ISP. This is basically the internet service provider which will provide you the internet. Alright, so the ISP is connected to the modem and the router. So the modem will work as a bridge between ISP and all the devices that are connected to this modem. Alright, device 1 is connected, device 2 and device 3. So these three devices are connected to this modem, and the modem is working as a bridge between ISP and all the devices. Alright, so these IP addresses will be assigned, these devices will be assigned different IP addresses. Alright, so device 1 will be assigned IP address 1, device 2 will be assigned IP address 2, and the device 3 will be assigned IP address 3. So these are the local IP addresses that will differentiate all the devices from each other. Alright, so the device 1 will be different from the device 2, and device 2 will be different from the device 3 with the help of these local IP addresses. Alright, so how the modem will assign the local IP address? So basically it will use the DHCP protocol. Alright, so DHCP protocol is a dynamic host configuration protocol. Basically these are the set of rules that will be helpful when assigning the IP address to the devices. Alright, so now you need to remember another thing, and that is the global IP address. So basically this global IP address will be used to identify on the server. Alright, so let's say this ISP is connected to the internet, and you send a request from device 1, device 2 and device 3. So these three requests are sent to this modem, and the modem will take these requests and send it to the ISP. Now the ISP will take these requests to the internet, and the internet will take these requests to the server. So the server will identify these three requests with the help of global IP address, that this global IP address has sent me these three requests. Because these local IP addresses will not be identified on the server, only this global IP address will be identified there. Alright, so the server will identify this global IP address and all the three requests. So after sending a request, the server will respond back to the internet. Alright, so the response will go to the internet and to that particular ISP which has a global IP address. So after receiving the response will go back to the modem, and after that the modem will differentiate all the devices that have sent the request. So let's say device 1 has sent a request from a web browser. So the data that has been sent from the web browser will be responded to the web browser or device 1 only. Alright, so let's say device 2 has requested from a MongoDB server. So the modem will take a specific data that is responded to the MongoDB server and transfer it to the device 2. Alright, and device 3, let's say, send a request from the chatting application. So the modem will send the data back to the chatting application because it is only specific to this device 3. Alright, so how it will identify the device? Basically, modem will identify a device using the network access transfer that send a request to the internet. Alright, so the modem will identify all these three devices, that which device has sent which type of request. So in this way the modem will distribute the response related to its own device. Alright, so now we have discussed how you can identify a device using net, but there is a question that how you can define application by using a modem. So to identify an application, let's say a device 1 has made a request from web browser also, and it also has MongoDB server open, it also has chatting application open. So only one device contains 3 or 4 types of application. So how the modem will identify these three applications, that which application has sent the request. So to identify this, let's move to another slide. Here is a question. And the answer of this question is ports will identify an application, that a particular application has sent a request from device 1 to the server. Alright. So in this way, the IP address will identify the device and the ports will identify an application using port number. So we have discussed that these IP addresses are just to differentiate the device, but the port numbers will be used to identify an application. Alright. So let's move again. And now you can see that these are two devices. Let's say these are chatting applications. So one chatting application sends a request using the IP address and the port number. So this chatting application will identify the device using IP, and the port number will identify an application that a particular chatting application sends a request. So after that, after identifying these things, the application will send the data back to this IP address and the chatting application. Alright. So in this way, the connection will be built and both persons can talk to each other. Alright. So after that, let's say what is port number. So port number is a 16-bit number that will identify an application. So basically what is bit? So bit is the smallest unit of information. So bit can either be 0 or it can either be 1. Alright. So these bits are the 16-bit numbers. This is the port number. So if I take the total of it, so 2 raised to the power of 16 will be equal to 65,000 ports. So basically these are the port numbers that will be used separately for each of the applications that are connected to the internet. So let's say web application has a port 1, for example, MongoDB server has port number 2, MySQL server has port number 3, similarly that chatting application has a port number 4. So these ports will be divided among different applications to identify an application. Alright. So after that, let's move to another slide and see what web pages are using HTTP protocol. Alright, so we have discussed in the previous video that what is protocol, what is HTTP, TCP, UDP protocols. You can watch this video if you want. So I will give the link in the description below also. So to receive the data in the browser, there should be a port number defined. We have discussed before that to receive a data in a browser or any application, you must define a port number to get the results. For this purpose, the ports are defined to get the result in a specific application. Alright. So for HTTP, the port is 80. So if 80 ports send a request to the server, so the server will give the response back to the 80 port. Alright, because it are requested from the web browser. Similarly, if a MongoDB sent a request to the server, so the server will send a request back to this port, 27017. Alright, so this so that data cannot be distributed with among other applications. Alright. So similar example with MySQL, so the port is for this 1433. If this port requested a data, so the data will only be responded back to this port. Alright. So after that, from 0 to 1023, the ports are reserved ports. So you can't use these ports. So, and after that, 1024 to 49,152, the ports are for applications only, such as MySQL, MongoDB, and etc. And the remaining ports that are starting from 49,152, the ports are remaining. You can use it for your own purpose. Alright. So, how to measure the speed of internet? So, basically, the measurement of speed will be in bits per second. Alright, so how many bits are transferred in 1 second will be the speed of internet. Alright, so how much kilo, mega or gigabits are transferred in 1 second, this will identify the speed of internet. Alright, so 1000 bits that are transferred in 1 second will be equal to 1 kbps, kilobits per second. Alright. Similarly, if 10 raised to the power of 6 bits are transferred in just 1 second, this will be equal to 1 Mbps, megabits per second. Alright, and that is also applied in the gigabits. If 10 raised to the power of 9 bits are transferred in 1 second, this will be equal to 1 Gbps. Alright, so sending the data from a computer to the server is called upload, and receiving the data back to your computer from a server is called download. Alright, so how does the communication happen between two computers? So basically there are two ways in which the communication will happen. The first one is guided way and the another one is the unguided way. So the guided way, it is showing by its name that it has a particular path in which the communication will happen. So let's take an example. So if path is already defined, then it is called guided way. Alright, so for example, two computers are connected with a wire. Basically, the wire will show the guided way that with the help of this wire, two computers are connected, and all the data that will be transferred between these two computers will not go somewhere else because the path is already defined. Alright, so now let's move to the unguided way. If there is not a single path, instead there are multiple paths, that will be called unguided way. Alright, so here is an example of Wi-Fi or Bluetooth. So for Wi-Fi or Bluetooth, there is not a single path. So let's say you are connected, the Wi-Fi is present in a particular location, so there will not be a single path for a computer to be connected. So let's say one computer is connected and then another computer is connected, but there is not a defined path for it. You will just enter a password and the Wi-Fi will be connected. Similarly, with Bluetooth, you will just connect many phone devices you can connect. Alright, so this will be in a particular location, so there will not be a single path defined for it. So after that, let's move to another slide, and that is how countries are connected with the internet. So before showing this slide, let's close this one and move to this tab. And as you can see that I'm in the website submarinecablemap.com. So here you can see that this is the map of the world, and these are a lot of wires, a lot of cables that are connected from one country to another country, or even one continent to another continent. Alright, so these are basically the cables that are showing us the connection between one place to another place. So this will define the internet, that how internet is connected from one country to another. So internet is not in the cloud, basically it is under the ocean and under the sea. So these are all the cables that is transferring the data from one location to another with the help of internet. Alright, so let's move to zoom in. And now you can see that this is North Atlantic Ocean. So these are a lot of wires. So if I click on any one of them, let's click on this one. So now you can see that this is the cable length, 14,301 kilometer is this cable length, and it is starting from United States, Brooklyn, to the Denmark. All right. As you can see that this is Germany. Sorry, this is Germany. These are all. This is the cable that is 14,000 kilometers. The owner of this cable is Lumen. Supplier is Subcom. It is the website of this owner. And these are the landing points in which the cable is connected. So it is landed in Germany, Netherlands, United Kingdom, and United States. All right. So show all the cables again. And then if I click and I move to the Asian countries, and if I take this cable, let's say, you will see that this cable has a length of 9,800 kilometers. The owner of this cable is also defined, supplier, this website, and these are the three landing points: Australia, Keeling Islands, and Oman. All right, so it is starting from here to this to Oman. All right, so let's zoom in again, show all the cables, and now let's zoom in again. And after that, let's click on this cable. All right. So there are. I will see the Pakistan in which the how many cables are connected here. So here in two cables are landing. First in Gwadar and another one is in Karachi. So let's look into the Gwadar cable. Click on this. And now you can see that this is so long. This length is so long that 21,500 kilometer of this cable length. And these are some of the owner of this cable, Peace Cable International Network Corporation Limited. And this is the supplier of this network. This is the URL, and these are some of the landing points in which the cable is starting from Malaysia, Singapore, sorry, and these are landing in different places and ending at the on the fronts. All right. So all the countries that are connected are starting from let's say one continent to another continent. It is going from Asia to Europe. Alright, so these are cables that are under the ocean. Alright, so basically internet is not on the cloud, it is basically on the under the sea. So if I say submarine cables, let's say submarine cables, and click on the images, now you can see that these are the submarine cables that are present under the ocean. Alright, let's click on another picture. These are the installation of cables that are present above the sea, but it is now installing under the sea. Alright, so it is touching the surface of the sea. Alright, so as you can see that these are touching the surface of the ocean. So as you can see that it has multiple layers. The last one is the layer in which the data is transferred, but all the upper layers are just to protect this one layer, so that it can't be harmed by a big fish or any other thing. Alright. So now let's move to the slide again and show the slide. So as you can see that the countries are connected with two ways. First one is physical connection and another one is wireless connection. So in physical connection, the optical fiber cables and coaxial cables are used. Basically, I have shown you that how the countries are connected, so the physical connection are used there. So for wireless connection, so to cover the small distance, Bluetooth and Wi-Fi are used. Alright, so these are for small distances to be covered. And 3G, 4G, LTE and even 5G will cover the big cities or some towns, etc. So these will be able to connect with multiple cities with the help of wireless connection. Alright, so now let's answer another question, that how things are connected with networks. So basically there are three ways in which the network will be connected. So the first one is LAN, and then main, and then at the end WAN. LAN is local area network, metropolitan area network, and a wide area network. So these are the network of computers present in homes or small offices. So let's say you have 10 computers, 20 computers that are present in a particular area. This network will be called LAN, local area network. So LAN is connected either with Ethernet, cable or Wi-Fi. After that, let's move to another network, that is metropolitan network. So this network is basically present across the cities. So they will connect the cities between each other. So a main is connected using optical fiber cables, and WAN is present across countries. Alright, so it will connect different countries. So it is also connected with optical fiber cables. So there are two things that you need to remember, and that is a SONET and frame relay. So SONET is a synchronous optical network that will carry the data using optical fiber cable to cover the large distance. Alright, and the frame relay, it is basically used to connect the local area network with wide area network. So it will basically connect the local area with a wide area using with the help of frame relay. So now discuss what is modem. We have seen in the previous slide that modem and a router are basically working as a bridge, but these things are not just limited, they are working more than that. So let's look at the definition of modem and a router. So the modem is a device that converts digital signal into analog signal and vice versa. So let's say you have an image that has a digital signal, and you want to transfer that digital signal of image to another computer. So how you can do it? So basically you will send the data, and the modem will convert that digital signal of image to electrical signals, and the electrical signal will be passed through cables. Alright, so when the cables will take this electrical signal and receive that if that electrical signal is received on another modem, the modem will convert that electrical signal back to digital signal. Alright, and in another computer the digital signal will be appeared as in the form of image. Alright, so let's say you have a digital signal that is image, modem will convert their data to electrical signal so that you can send it through some cables. Alright, so now let's look at the router. So router is a device that routes the data packets based on the IP address. So what does it mean? So let's say you have three devices that are connected to the internet. So device 1 send a request from web application, device 2 send a request from MongoDB server, and device 3 send a request from chatting application. Alright, so all the requests will be sent to the ISP. The ISP will then send the data to the server. Alright, so now the server will respond back to the ISP. The ISP will respond to the router and a modem. Alright, so the modem will take the signal to take the analog signal and give it to the digital signal, convert it to the digital signal. And the router will do, what will the router do? The router will differentiate each of the requests. Alright, so if let's say a request was made using web application, so the router will only send that data to the web application because that request was made using web application. Or let's say if a person send a request to the MongoDB server, so the router will send that response to the MongoDB server. Alright, and let's say if a person send a request to the chatting with the help of chatting application, so the router will send the response back to the chatting application. So it won't distribute the response randomly. So basically it will define a path for it and differentiate multiple devices, so you can so it will be possible to distribute the data in this way. So in this way, if a device A searched a website, it will be only open on that device only, not on other devices. Alright, so that's it. I hope you like this video. So if you have liked this video, then make sure to subscribe to my channel, and if you have any questions, then please ask these questions in the comment section below. I'll be happy to answer all of your questions. So till then, goodbye.